When finding the limit of a function as x approaches a, and plugging in a for x like usual doesn't work, we can use the squeeze theorem. Let's look at a quick example. Here we want to find the limit of x squared times sine of 1 over x as x approaches 0. But if we plug in x equals 0, we're going to get 1 over 0, which is undefined in math. So we're going to have to use the squeeze theorem. So what is the squeeze theorem? Well, it's actually very simple. Let's say we have three functions, f, g, and h. Let's say f and h are the outside functions, and g is always squeezed in between it. That means that it's always in between the functions or equal to them. All the theorem says is that if the outside functions both approach the same y value at a certain x value, then the middle function also has to approach that y value at that x value. So when we look at this graph, it's clear that the outside functions at x equals 0 both approach a y value of 0. Therefore, g of x, which is sandwiched or squeezed in between the outside functions, must also approach y equals 0 at x equals 0. That's all the squeeze theorem is. So here are the steps. First, we find the problematic part of the function. In other words, what prevents us from just plugging in x equals a. Next, we pick our outside functions. One is going to be greater and one is going to be smaller than our problematic part. Sometimes the problematic part has bounds, and that can help us. Once we find our outside functions, we can make an inequality and put the problematic part in between the outside ones. Then we have to multiply our inequality by whatever is needed so that the middle problematic part looks like our original tricky function. Then we just use the theorem. So it's a lot of steps, but it's not so bad. Let's take a look. Going back to our example here, the problematic part is sine of 1 over x. We know from trigonometry that sine is always in between -1 and 1. Now let's make the middle part look like our original. Multiply the whole inequality by x squared. Now we're ready to use the squeeze theorem. As x approaches 0, the left part of our inequality has a limit of 0, and the right part of our inequality has a limit of 0. Therefore, the middle part of our inequality, which is the function we were tasked to find the limit for, also approaches 0. And that's the squeeze theorem.